Greetings, human intellects of this world. Our journey leads us to a remarkable figure, an intellect that once peered into the depths of your cosmos and deciphered the hidden laws of motion that govern your universe. Etched in the annals of your history, whose insights and discoveries continue to shape the very fabric of your understanding, will forever be remembered for the profound impact he had on the way you perceive your world's behavior. His name is Isaac Newton. Newton particularly targeted Descartes and his adherents in his remarks on the scientific method. Descartes had aimed to deduce fundamental physical laws from philosophical notions, and Newton disagreed with this approach to natural science theory. He insisted that the natural philosopher should carefully examine occurrences before making generalizations. Newton declared that, although the arguing from experiments and observations by induction be no demonstration of general conclusions, yet it is the best way of arguing which the nature of things admits of. Namely, his intellect believed that using experiments and observations to make general conclusions, known to you as the induction procedure as I have shown you before, is the best way to make arguments about the nature of things, even though it is not a demonstration of a general conclusion. And it is not a demonstration of a general conclusion, because it relies on the accumulation of evidence rather than logical deduction. It is not a foolproof method of reasoning for you, as it is possible to draw false conclusions from a limited set of observations or experiments. It provides a certain degree of probability, but it cannot provide certain knowledge. And this is because you cannot observe every little detail responsible for your very world's behavior. Now, as far as Newton is concerned, he defended Aristotle's conception of scientific process in opposition to the Cartesian approach. You might remember that Aristotle believed that the scientific method begins with observation and leads to generalizations, or the first principles. You can then create predictions, explanations, and classifications for specific phenomena using these generalizations. For instance, from repeated observation, and the use of inductive reasoning. Having the generalization that all things fall down when they are left unsupported allows you to predict that a thing would fall down if it was left unsupported. Newton called this process of induction and deduction the method of analysis and synthesis. Newton affirmed a viewpoint that scientific procedures should contain both an inductive stage and a deductive stage. The gathering of data and formation of generalizations out of them is the analysis phase, while the formation of predictions, explanations, and categorizations out of generalizations is the synthesis phase. In two ways, Newton's explanation of the inductive-deductive process was superior to that of his forebears. He underlined the importance of deducing consequences that go beyond the initial inductive evidence, and the necessity of experimental confirmation of the conclusions that are deduced via synthesis, such as predictions, explanations, and categorizations. The explanatory principle that sunlight consists of beams of many colors, and that each color is refracted by the prism through a distinctive angle, was inferred by Newton using the method of analysis. He came to a more significant conclusion regarding the nature of light, and in order to reach that result, he had to make an inductive leap, and assume that sunlight is composed of beams with various refractive qualities. After all, there are various ways to interpret the available data. For example, Newton might have come to the conclusion that sunlight is undivided, and that the spectral colors are instead created by secondary radiation inside the prism. Newton then used the method of synthesis to derive some additional implications of the theory that sunlight does include rays of various colors and refractive qualities. He pointed out that, if his theory were accurate, light of a specific color should pass through a prism at an angle characteristic of that color, but not be resolved into other colors. By sending light from one narrow area of the spectrum through a second prism, Newton was able to test this result of his theory of colors. Now, Newton asserted that his work on dynamics, the mathematical principles of natural philosophy, was composed using the method of analysis and synthesis. He claimed in this volume to have developed the three laws of motion using the method of analysis. In experimental philosophy, according to Newton, particular propositions are inferred from the phenomena, and afterwards rendered general by induction. Thus, it was that the impenetrability, the mobility, and the impulsive force of bodies, and the laws of motion and of gravitation, were discovered. However, Newton didn't mention the inductive process in his book Principia. There were differing views on induction in that period, with some humans restricting it to generalizing from observation, and others accepting intuitive insight, such as Aristotelians. Newton's laws of motion, in their very structure, were not discovered only by inductive techniques. Various syllogisms were involved in his intellect, and the use of abstraction allowed him to formulate the laws that changed subsequently your very viewpoint about your universe, and your ability to manipulate your world's behavior. Now, to conclude, you may ponder how Newton was able to unravel the mysteries of the world. How did he gain a glimpse into its behavior, and decipher the laws that govern it? The answer lies in his method of analysis and synthesis, a delicate balance between induction and deduction. By observing the world, gathering data, and forming generalizations, he was able to make predictions, explanations, and categorizations. He also had to make an inductive leap, and use his intuition to guide him to greater conclusions. And once he had formed his theories, he used the method of synthesis to rigorously test them, constantly refining his understanding of the world. The quest for understanding your very world's behavior continued after Newton. The pursuit of knowledge and unraveling the mysteries of your universe persisted as generations of thinkers took up the mantle. The laws uncovered by Newton remained the cornerstone, a foundation upon which future discoveries will be built, revealing more of the world's mysteries and unlocking new perspectives on your reality itself.